In the next 2 years, spaceflight enters a different phase. Not a single headline, but a chain of missions that quietly changes what's possible. Humans are set to fly around the moon again. The Lunar South Pole becomes a strategic destination. Commercial stations begin to test whether orbit can become a real marketplace. And new telescopes prepare to map the sky with a scale and precision we've never had before. This is a short window, 2026 and 2027, but it sets up the next decade. So let's walk through the missions, what they're trying to do, and why each one matters. Artemis II is the first crewed mission of NASA's Artemis era. It won't land on the moon. It will do something equally important: prove that humans and hardware can operate beyond low Earth orbit again. The mission is a full systems test in deep space: life support, navigation, communications, and a high-energy return to Earth that pushes re-entry and the heat shield to their limits. If Artemis II works, the argument changes overnight. A crewed lunar flyby isn't the finish line. It's the key that unlocks everything that follows. And the moment that happens, the moon stops being a distant symbol and starts becoming a destination with logistics. The Lunar South Pole is the prize, because in permanently shadowed regions there may be water ice, and water is more than survival. It's oxygen, it's fuel. It's the difference between a visit and a foothold. That's why multiple programs are aiming missions toward that region, including China's Chang'e 7, often described as a South Pole-focused scouting mission. But the most important change is quieter than a landing. It's infrastructure, communications relays, navigation services, the systems that make the moon feel less like an expedition and more like a place you can operate around repeatedly. When that invisible network is in place, everything scales: landers, rovers, cargo, and eventually human surface work that doesn't depend on perfect conditions every single time. Now, closer to home, low Earth orbit is entering a transition. For decades, the model was simple: one dominant station, a limited number of vehicles, and access controlled largely by government programs. Over the next 2 years, the new model starts to appear: multiple commercial destinations and more varied spacecraft. Even small private stations matter because they test a real question: can orbit support a sustained economy, research, manufacturing, national astronaut visits, and commercial payloads without being anchored to a single government outpost? This isn't just a business story, it's continuity. As the ISS ages, the world needs a path to keep human activity in orbit alive, and commercial stations are the likely bridge to that future. Planetary defense used to sound like a plotline. Could we actually move an asteroid? Then NASA's DART mission delivered a real impact, a deliberate collision designed to change an asteroid's motion. But one hit isn't enough. To turn a dramatic moment into engineering, you need measurement, close-up science that tells you what changed, how it changed, and why. That's where ESA's Hera comes in, a mission designed to study the DART target system up close and quantify the results. Because if we ever face a real threat, there won't be time to guess. We'll need data on how different asteroid types respond: solid rock, rubble piles, fractured bodies, and what it takes to shift their trajectory. In the next 2 years, planetary defense moves from theory to calibration. Asteroid missions aren't just about visiting a rock, they're about retrieving a record of the early solar system, chemistry that planets often erase through heat and geology. China's upcoming small body plans, including asteroid exploration and sampling objectives described publicly in mission outlines and reporting, are part of that larger trend, samples as evidence. Because a sample isn't an image, it's a laboratory object, something you can test for organics, isotopes, water-related minerals, and the fingerprints of ancient processes. In other words, these missions aren't just about where an asteroid is. They're about what it is and what it can tell us about how worlds form. While rockets pull attention downward, telescopes push our attention outward. And 2026 to 2027 is a setup window for a new era of sky surveys. NASA's Nancy Grace Roman Space Telescope is built for wide-field precision, mapping cosmic structure, probing dark energy, and hunting exoplanets through microlensing, events so subtle you only see them by watching huge areas of the sky patiently over time. And ESA's PLATO is designed to find and characterize planets around nearby stars, especially worlds that can be compared, not just discovered. Not a single hero image. A steady stream of measurements that changes our baseline for what's common in the galaxy. These missions are slow burns, and that's exactly why they matter. Now Mars adjacent but crucial. Japan's MMX mission targets Phobos, with a campaign designed to observe, operate, and ultimately return samples. The question sounds simple: what are Mars moons? Captured asteroids or debris from an ancient impact on Mars. A Phobos sample could settle that with chemistry, the kind of answer you can't fake with just imagery. 2010 is also a demonstration of something bigger: navigation and operations in the Mars system, the kind of capability that quietly builds the toolkit for future Mars logistics. So when you look at 2026 and 2027 as a whole, the pattern becomes clear. This isn't a single race. It's a shift into an ecosystem. Crewed missions that restart deep space operations. Lunar South Pole scouting that turns ice into strategy. Commercial stations that test whether orbit can become a lasting marketplace. Planetary defense that becomes measurable engineering. And telescopes that prepare the next decade of discovery. If you want, in the next videos, we'll go mission by mission. What's real, what's risky, what could slip, and what to watch for when launch windows open. If this roadmap helped you see what's coming, hit like, subscribe, and tell me in the comments which mission you want first. Artemis II, the Lunar South Pole, Hera, Roman, or 2010. Because the next 2 years aren't just busy, they're formative.